All right, today we're going to look at the RTX 4000 from Nvidia. We're going to cycle it through Solidworks, the Solidworks benchmark tool, visualize Furmark, and something else. Oops. Just kidding, not anything else, just those four. Let's take a look. All right, folks, the first thing we're going to look at today is how this RTX 4000 does with this enclosure assembly. Now, I really like this assembly because it has a lot of little components, a lot of little detail. You can go ahead and hide some stuff here so we can see what's on the inside. Yeah, lots of really good stuff on the inside. We got the trays, inside outside faces, rather increases graphic triangle count. Lots of detail and a pretty good little model for something, you know, intermediate to basic, I suppose, depending on you know, what sort of things you are designing. Let's go ahead and look at our assembly, or performance evaluation rather. Go and scroll down here. You can see that there are about 321 parts, that there is an assembly depth of 5, total number of mates is 135, and there should also be a place in here for graphics triangles. There we go, quantity graphics triangles. So some of the parts are, you know, relatively large, but as far as graphic triangle count goes, these are pretty straightforward. All right, so what we're going to do is we're going to monitor our GPU usage. Notice that I have the Quadro RTX 4000. Oh, let's just go ahead and expand that a little bit more. There we go, RTX 4000. And what we're really doing here is we're just looking at how the GPU is pegged inside the task manager, and then if we lose any frames inside of our user interface here, right? So I'm going to use the arrow keys first. We'll see how the RTX 4000 handles a simple rotate. Super snappy, not losing any frames, really good. And we'll go ahead and use the 3D mouse now to do some rotating and some panning. Oh, let's turn that add-on in. Turn it on. Okay, so now we're using the 3D mouse. I'm just gonna rotate this thing and pan and zoom. We'll see if we can bring it back. I'm just trying to not brag about my 3D mouse skills, right? But I'm trying to peg the GPU. Looks like we're getting about 16%, and that's about the most that I'm seeing here. 15, 16, yep, that's about it. If I use my center mouse button, I can get it up to about 33, 32. This is just using the center mouse button on your mouse. 32% is about where I'm maxing the RTX 4000 out, which I've got to say is really impressive. Seems like there's a lot of room in there for some bigger files and some more processing power. So super happy with that. Next, we're going to trek over to something vastly more complicated, right? 80,000 components. This is the telescope / observatory file, right? Let's go ahead and take a look at this guy. Here we go. You may have seen this in some of my other examples that I've done for GPU benchmarking, but this is a really heavy file, and I would say this is a pretty complex assembly here. So we're going to start off with the arrow key rotate. So if I smash the arrow keys, right, there's a delay. But if I wait for it to you know, if I wait for the command to finish, then it's pretty happy. So it's like, you know, left arrow, left arrow, left arrow, right arrow, right arrow, right arrow, as opposed to just like smashing the left key and then having the delay happen, right? So that's kind of expected. I you know, for an $800 GPU, I think this thing's working fantastic so far. Let's go ahead and use the 3D mouse. We'll just kind of do some rotates here. See if we lose any frames, and see how the GPU gets pegged in our task manager. Okay, looks pretty dang good. We're gonna have 34%, 35%, much more room than I actually expected for this RTX 4000. Super impressed actually with how well this thing is doing. Okay, the next test we're gonna do is just with the center mouse button on your mouse for rotate. So I'm gonna go ahead and rotate this thing, and get up to about 51%, 53, 55, 54. All in all, though, I'm kind of shocked. For much less money than, say, an RTX 5000, an RTX 4000 is handling this like a champ. Let's try changing the shaded mode and see if we can tax this thing a little bit more. So we got up to about 55%. Let's see if we get it up a little bit higher. This will take a second. All right, while I was waiting for that shaded option to complete, I did notice that my GPU temperature was at 57 degrees. It started off at 35 degrees C, and now it went up to 57, dropping as the GPU fan kind of kicks in. I can also hear the GPU fan just a little bit, but completely normal, I think, considering. Also notice the GPU temperature spiking when I'm rotating these things, 62, 63, 64. So you're going to want to make sure you have enough room for this GPU in your box so that it gets some good cooling. That default fan seems to be working pretty nicely. Oh, and finally running into some issues with the RTX 4000. I knew this file was a little heavy for it, right? Just a couple frame rate losses, not something that's a deal breaker by any means, I think. Just lost a couple frames there on the screen. I think as that temperature heats up, you're going to see maybe some frame rate losses, kind of where I'm kind of seeing this. Now we're able to get this thing up to about 62%, 63% on the GPU usage. The GPU temperature spiking to 73, 74 C right now. Just as a reference, with the RTX 5000, I wasn't able to get anything past 35 C, 36 C using the RTX 5000 in SolidWorks. So this RTX 4000 seems to be paired really well, and actually probably is an excellent choice for most SolidWorks users. All right, so now we're jumping into Furmark, and we're just going through the process, the 720p default stress test to see how the RTX 4000 performs, if there's any throttling, what's the maximum temperature, and just put it through like an extreme load case, I suppose, to really test its functionality. Now that it's complete, we can see the score. I went ahead and submitted it online so you can compare it to other GPUs and maybe your GPU. Now, if you like this video so far, be sure to hit the thumbs up. And if you have any comments on different stress tests I can use, let's do it, right? Write it in the comments, let me know. So the next thing we're looking into right now is the SolidWorks benchmark tool. You can go to the home icon on the right-hand side of your SolidWorks key and hit the benchmark icon and run the benchmark yourself. That way you can compare your computer and, say, your graphics card and CPU amongst other users who are also running the same sort of benchmark. Now, this benchmark operation is rather long and tedious. So you want to go make a sandwich or make a lunch or make a snack while this thing's running. The idea is that you're not using any other pieces of software, not doing anything else on your computer while it's running. Unfortunately, since I'm recording, I'm kind of avoiding that whole thing. But this is the closest we can get to an actual live benchmark that I can share over the internet, that I can share with you via YouTube. Keep in mind, this was run at 20x. So we're just speeding through this process, and I'm showing you the results at the end. Let's take a look. Here's also. All right, the next thing we're gonna take a look at is how the RTX 4000 performs inside of Visualize. And we're just gonna do a pass count. So we're gonna take a look at how long it takes on the same model to reach a certain number of passes and compare it with other models. All right, the last test for this RTX 4000 is to see how it does in Visualize rendering. So here I have a slightly complex model with some very good lighting in it, plain backdrop. We're gonna reset the render and then just figure out how long this takes to render and then compare it with the RTX 5000, RTX 4000, that's what this card is, and the Radeon Pro V7. So let's give this a go. Here we're looking at like 50, 60, 70 passes a second, ramping up to 75, plateauing at 75 passes a second. And we'll see how long it takes to get to 1500. And we're there. Great. So I plan on comparing this to the RTX 5000, 4000, which is this card, and the Radeon Pro V7 when I get all that data in, and I'll make sure to combine it all together here. All right, so here's my final thoughts on the RTX 4000. I think that this is the winner, right? The RTX 4000 is at the right price point with the right performance to really maximize your dollar when using it in SolidWorks. So they're paired very well together. When I was rotating, I saw like 80% usage, which was good, right? Like I'm not pegging it out, but and it still has some more room, but I'm not losing performance on the SolidWorks interface side. Likewise, I didn't have to spend an extra $1,000 to maybe upgrade. So I'm going to be testing the RTX 5000 next. And what I'm going to do there is something maybe a little different. I'm going to do the normal SolidWorks stuff and the visualized stuff, of course. But I'm going to combine the two together and see really if that's where the cost benefit kind of comes in. Are you doing all of this multitasking simultaneously? And if so, does that justify the upgrade to the RTX 5000? Check out this video and we'll find out together. If you like this video, be sure to hit the thumbs up and be sure to smash the subscribe button down there at the bottom. If you like this video and you want to see more, feel free to write some comments in there what you'd like to see. Also, if you watch this video all the way through, I can't thank you enough. This is Adam Hughes. Fight on.